Hello everyone and welcome to our discussion. For today's lesson, we'll be going to discuss what is thermochemistry. But before that, let us first know the following terminologies and concept that is included in the word thermochemistry. First is the flow of energy. We all know that the energy is the capacity to do work or supply heat. It has no mass or volume. Aside from the potential and the kinetic energy, we also have this chemical potential energy that is stored in every chemicals. By just merely looking at the kinds of atoms and the arrangement of the atoms, we can now determine the amount of energy stored in the particular particles or in a particular substance. So we have now the flow of the heat energy. Heat is a form of energy that always flows from warmer body or warmer object to a cooler object, and there is no such thing that from the cooler to warmer. Heat is represented by a small letter Q. So we have here a scenario. What do you think will happen if chemical and heat will be combined? The possible answer for that would be there is a chemical reaction. When there is a chemical reaction, there is a new production of product, or shall we say production of a new product. When chemical reaction occur, that's the time na papasok na si thermochemistry. Thermochemistry is the study of changes of heat that occur during chemical reaction and physical changes of state as stated here. So in short, thermochemistry is a branch of thermodynamics that focuses on the study of heat release and heat absorbed during the chemical reaction. The first law of thermodynamics states that in any chemical or physical process, energy is neither created nor destroyed, but it can be transformed into another form of energy. For example, from the solar energy going to chemical or from chemical going to mechanical. That is the transformation of energy. So those chemical reactions were classified into two. So we have here exothermic reaction and the endothermic reaction. And we will discuss that two later. So in thermochemistry, it is only concerned with the flow of heat between a chemical system, the reaction, and its surrounding. So kung napapansin natin dito, we have this chemical system and its surrounding. In thermochemistry, we have these terminologies that we need to understand in studying thermochemistry. First terminology is a system. A system is a specific part of the universe on which you focus your attention. When you focus your attention to something, that something can now become a system. For example, when I focus my attention to my hand, this hand can now be a system. When I focus my attention to this one, my cell phone, this cell phone can now be a system. So the next one, the surroundings. Outside from this system or a system, that can now be our surrounding. So the next terminology is the universe. System plus its surrounding constitute to a universe. So that is the terminologies that we need to understand in thermochemistry. So kanina, we have classified the chemical reaction into two. We have the exothermic and the endothermic. In thermochemical calculation, the direction of the heat flow is given from the point of view of the system. Kumbaga, nakadepende lang po ang direction of the heat to the system. Si system po ang may hawak ng direction of the heat flow. So in the process, a process that absorbs heat from its surrounding, when When a system absorbs heat from its surrounding, that kind of process will now be called as endothermic process. And when that system or process loses heat to its surrounding, that process can now become an exothermic process. So those chemical reaction has a very common difference when it comes to absorption and release of heat. By just simply looking at the absorb and release of heat or losses of heat, we can now identify endothermic process from exothermic process. So next one is the units of heat. In the units of heat, calorie is the quantity of heat that raises the temperature of 1 gram of pure water 1 degree Celsius. This calorie is the quantity or the units of heat na ginagamit natin. So second, a calorie or a dietary calorie, capital letter C, is equal to 1,000 calories. In this presentation, we are now going to the conversions of heat from calorie into joules. Next one, a joule is a system unit of heat and energy, and wala nang iba pa. So now is the conversion. In 1 calorie, capital letter C, is equal to 1,000 cal. 1,000 cal is equal to 1 kilocal, and in 1 kilocal, it is equivalent to 4,184 joules. In 1 cal, small letter C, it is equal to 4.184 joules. So that is the conversions of the heat from calorie, capital letter C, going to the small letter c. So let's practice our conversion. Let's proceed to the energy conversions. So we have here a following example. Make the following conversions from calories to joules and joules to calories. First example is 444 calories to joules. Ano bang gagawin natin? So we just simply convert 444 cal to joules. Ano bang step niya? It is just a simply multiplication. 444 calories times 4.184 joules divided by 1 cal. It is because in 1 cal, it is equivalent to 4.184 joules. Just simply cancel cal at ang natira is letter J or joule. So now, let's multiply 444 to 4.184 joules. It is equivalent to 1,857.7 joules. What if joules to calories? Ano bang gagawin? Paras pa rin sila. So, 850 joules times 1 cal naman sa taas divided by 4.184 joules. Just cancel letter J or joule at then ang natira is cal. 850 divided by 4.184, it is equal to 203.2 cal or calories. Let's proceed. The next one is the heat capacity. The heat capacity of an object is the amount of heat it takes to change an object temperature by exactly 1 degree Celsius. This heat capacity is one of the, shall we say, it is a level gauge of a particular substance. When the level is obtained, that is automatically the temperature of that object will increase in exactly 1 degree Celsius or mas higher pa. The next one is the greater the mass of an object, the greater the heat capacity. So, heat capacity also depends on the mass. When the mass of an object is greater, its heat capacity would also be greater or tataas rin siya. For example, 100 grams of aluminum has a higher heat capacity compared to 50 grams of aluminum. It is because nakastate dito na the greater the mass of an object, the greater the heat capacity. Aside from the mass of an object, the heat capacity also depends on its chemical composition. Once the chemical composition of a substance is strong, there is a possible tendency or a big tendency that its heat capacity would also be stronger because its chemical composition is barely strong. So what is the formula of heat capacity? So we have here CH equals to Q divided by delta T. So C stands for heat capacity. Nilagyan lang natin siya ng heat. For us to identify that is heat capacity. Q stands for heat absorbed or release. And then delta T, it is the change in temperature. What is the units being used in heat capacity? We use joules per degree Celsius. And heat capacity is considered as extensive property because it depends on the amount of that materials, gaya ng sinabi ko kanina. Kapag mabigat ang isang bagay, the heat capacity would also be greater or mataas. The next one, specific heat. The specific heat capacity of a substance is the amount of heat it takes to raise the temperature of 1 gram of substance 1 degree Celsius. This specific heat is the heat that we need to add in a particular substance to make its temperature increase by 1 degree Celsius. So, specific heat is represented by letter C. The units that we use are joules per grams per degree Celsius. And water has a higher specific heat than most substances. Bakit nga ba water ang may higher specific heat compared to those of the substance? It is because higher can hold more thermal energy compared to another substances. So, what is the formula of specific heat? So, we have here CS or specific heat equals Q divided by M times delta T. So, CS stands for specific heat, Q, heat, absorbed or released, then the delta T change in temperature. This letter M stands for mass. What is the units being used? The units being used is joules per grams per degree Celsius. It is an intensive property because it depends on the identity of the substance. Unlike heat capacity, specific heat does not depend on the amount or the mass of the substance. It just only depends on the identity of the substance. Nakadepende siya sa kung anong klaseng substance yan siya. For example, water has a higher specific heat compared to metal. It is because water has a higher or can absorb more thermal energy compared to metal. I will give you a scenario. Ano bang mangyayari sa isang metal once nilagay natin to siya sa isang mainit na lugar? Possible within 5 seconds, yung metal na yun is iinit at iinit. Comparing to water na kapag nag-boil ka ng tubig, then after how many minutes pa bago kukulo yung tubig, it is because the specific heat of water is more compared to the particular substance. Yun lang. And in specific heat, the greater the specific heat, the lower the change in temperature. Kapag mataas ang specific heat ng isang substance, mababa lang ang kanyang change in temperature. Tandaan pa natin yan. So next one, we have here the molar heat capacity. In molar heat capacity, it is the amount of heat needed to raise the temperature of 1 mole substance by 1 kilogram. So in molar heat capacity, we are also referring to the mole of a substance. So the system unit for molar heat capacity is in joule. So molar heat capacity is expressed in terms of joule per mole times Kelvin or per Kelvin. So what is the formula of molar heat capacity? The formula of molar heat capacity is ito. molar heat capacity is equal to Q divided by N, stands for mole, times delta T. Cm stands for molar heat capacity, N mole, and delta T change in temperature. So those are the formula of specific heat, heat capacity, and molar heat capacity. So this time, let's try to apply those formula in a particular problem. So we have here a problem stating that 1000 joules of heat is applied to 10 grams of iron metal and to water. Calculate the temperature change of this substance. So in this problem, we'll be going to calculate the temperature of the following substance. We have the iron metal and the water. So first, hahanapin muna natin ang temperature change of metal. So we will just going to apply this formula. Q is equal to M cat, or heat is equal to mass times heat capacity times change in temperature. So let's now substitute the following given numbers. So for heat, let's substitute 1000 joules. So we have here 1000 joules is equal to 10 grams of iron metal. Then the heat capacity of that iron metal is 0.45 joules for the specific heat. And then, let's multiply that by the change in temperature divided by grams per degree Celsius. So, ang gagawin na natin dito is to cancel grams per Celsius. So, ang natira is, 1000 joules is equal to 4.5 joules per degree or degree Celsius times change in temperature. Ang gagawin natin is to divide both sides by 4.5 joules, then cancel 4.5 joules, and then ang natira is, ito na lang sila. So, 1000 joules divided by 4.5 joules is equal to 222.2 degree Celsius. So, that is the temperature change of the metal when we put or when we apply 1000 joules of heat. The next one, we'll be going to calculate the temperature change of the water. So we have here the temperature change of water. We'll just follow the following formula. 1000 joules is equal to 10 grams of water with a heat capacity of 4.184 joules per grams degree Celsius times change in temperature divided by grams per degree Celsius. Just cancel grams per degree Celsius. So, ang gagawin na natin is to multiply 10 times 4.184 and the answer is 41.84 joules per degree Celsius times change in temperature. So, let's cancel or let's divide both side by 41.84 joules per degree Celsius. So, cancel, then cancel. So, 1000 joules divided by 41.84 joules is equal to 23.9 degrees Celsius. So, that is the temperature change of water. Kung napapansin natin that between the two substance, iron metal and the water has the smaller temperature change. It is because the higher the specific heat, the lower the temperature change. So, ang temperature or ang heat capacity po ng water is we have 4.84 comparing to metal na 0.45 lang. At automatically, we can now determine that water has a lower chance of temperature change. So, next problem, 1068 joules of heat energy was applied to 50 grams of aluminum metal. The temperature changed from 21 degrees Celsius to 45 degrees Celsius. What is the heat capacity of this metal? Calculate the specific heat and molar capacity. So in this problem, the following question is, what is the heat capacity of the metal? Then we will be going to calculate the specific heat and the molar heat capacity. So first, we'll be going to get the heat capacity of the metal. So we'll just apply the formula of heat capacity. So heat capacity is equal to Q divided by delta T or change in temperature. 1068 joules divided by 45 degrees Celsius minus 21 degrees Celsius, that is the temperature change. And then 1068 joules, 45 minus 21, that is 24. So 1068 divided by 24, the answer is heat capacity 44.5 joules per degree Celsius. That is the heat capacity of the aluminum metal. So next is, we'll be going to calculate the specific heat and molar heat capacity. So this is the formula. Heat capacity is equal, specific heat is equal to heat divided by M times delta T. So 1068 joules divided by 50 grams of aluminum metal, that is its mass, then times 24 degrees Celsius, that is the temperature change, and then 1068 joules divided by 50 times 24, that is 1200 grams per degree Celsius. And then I'll just going to divide the two, and the answer is 0.89 joules per degree Celsius. The next one, how about the molar capacity? The molar capacity, so we'll be going to follow this formula. So 1068 joules divided by 1853 mole, it is because in a 50 grams, we'll be going to convert 50 grams of aluminum metal into mole. So the equivalent is 1.85 per mole times 24 degrees Celsius, the change in temperature. So the answer is 24.02 joules per mole per degree Celsius. So let's proceed. We all know that the heat flows comes from the warmer body to the cooler body. So in heat, we have this kind of formula. So heat is equal to mass times specific heat times change in temperature, or shall we say the Q is equal to mcat, or the change in enthalpy or change of heat is equal to mcat. Mass is in grams, and then specific heat is in joules per grams per Celsius, and change in temperature is in degree Celsius. So let's review. In what direction that heat flows between two objects from the warmer to cooler? How the endothermic process differ from exothermic process? So by just knowing the heat absorbed and the heat release. Heat release and heat absorbed lang pagkakaiba nila. On what factors that the heat capacity of an object depends on? Heat capacity depends on the mass of the substance and the chemical compositions of a particular substance. So in number 4, let's just going to convert the calories to joules. So anong gagawin natin? Just simply apply the QMCAT. So for the QMCAT, the mass is 32 grams of water. Then the specific heat of water is 41, and this is, shall we say, constant. Then just multiply to the change in temperature of the particular water, 80 degrees Celsius to 25 degrees Celsius. So that is 55 when we're going to subtract. So the answer is 7,363.8 joules, and that joules will be going, and that joules is, i-convert natin siya into calories. 7,363.8 joules times 1 cal, then divided by 4.184, the answer is 1,759.9 calories. So the next one, how many kilojoules of heat are absorbed when 1,000 grams of water is heated from 18 degrees Celsius to 85 degrees Celsius? Just following the QMCAT, 1,000 times water pa rin, 4.184 joules per grams per degree Celsius times change in temperatures, which is 67 degrees Celsius. The answer is 280,328 joules, and we'll be going to convert that into kilojoule. So 280,328 joules times 1,000 kilojoules is equivalent to 1,000 joules. So we're going to divide 280,328 joules divided by 1,000 joules equivalent to 280.328 kilojoule. So this time is the measuring or expressing enthalpy changes. Calorimetry is the accurate and precise measurement of heat change for chemical and physical processes. This calorimetry is, shall we say, the process in getting an accurate measurement of the heat change in a particular substance during a chemical and physical processes. And they use calorimeters as a device to measure the amount of heat absorbed and released during the chemical and physical processes. So in enthalpy is the heat constant of a system at constant pressure. And enthalpy is represented by H. So this enthalpy is, shall we say, the heat of that particular substance. So this one is the calorimeter. So this one is a bump calorimeter. It is because the sources or the source of heat is being covered by a, shall we say, enclosed with this one. Then outside that object is may tubig dito. Then may thermometer. So by just using this calorimeter, they can now identify the heat release and absorb of this particular example. So in calorimeter, we also use the QMCAT formula. So heat change sign convention. So we have here a table that shows the heat change sign. Direction of flow of heat, sign, and reaction type. When the heat flows out of the system, the sign is negative delta H, and that type of reaction is exothermic negative. Heat flows into the system, papasok sa system, positive, and that is endothermic process. In enthalpy or delta H or change in heat, we have this initial state and the final state. In initial state going to the final state, magkakaroon po yan siya ng process. In this process, dito po yun mangyayari ang release of energy. When the final state or the products has a absorb heat from its surrounding, so this one would be endothermic process. It was because it absorbed energy from its surrounding during the process of the production of the new product. So that is the concept in enthalpy, the initial state and the final state. So next one, thermochemical equation. So thermochemical equation is an equation which includes the heat change. So this chemical equation is the expression of the following chemicals kung ano ba ang nangyayari sa mga ito. A heat of reaction is the heat change for the equation exactly as written. So we have here the following symbols of the chemicals or compounds as shown below. So yan na po sila. So example dito, when 2 mole of solid magnesium combined with 1 mole of oxygen gas, 2 mole of solid magnesium oxide is formed and 1,204 kilojoules of heat is released. Write the thermochemical equation for this combustion reaction. In writing the thermochemical reaction, we're just going to simply copy the given number. First is, ano po, 2 mole of magnesium. Solid siya. Then plus 1 mole of oxygen gas in a gas form. Then a solid magnesium oxide is formed. So we have here the solid magnesium oxide is formed. Then the heat release is negative 1,204 kilojoules. It is because, why negative? Kasi nga release outside the system. Nag-release siya, and that process is exothermic process. So dito, how much heat is released when 12.5 grams of ethanol burns? So it is the answer. Yan po ang answer. Yan po ang formula niya. So next, heat in changes of state. The heat of combustion is the heat reaction for the complete burning of mole of a substance. Heat combustion is the heat reaction. So, the heat reaction of the complete burning of mole of a substance. So, we have here the heat absorbed by 1 mole of a substance melting from a solid to a liquid to at constant temperature is the molar heat fusion ang tawag sa kanya. Molar heat fusion. When the heat loss, when 1 mole of a liquid changes to a solid, liquid to solid, the constant temperature is the molar heat of solidification. From liquid to solid, molar heat solidification. So, from liquid to vapor is the molar heat of vaporation. So, that is the heat reaction in the heat combustion. The next one is the heat released by 1 mole of a substance changing from vapor to liquid is the molar heat of condensation from vapor to liquid. Then the heat change caused by dissolution of 1 mole of a substance is the molar heat of solution. So we have here an example. So let's now proceed to the calculating heats of reaction. Hess's law of heat summation states that if you add 2 or more thermochemical equations to give a final equation, then you can also add heat changes to give the final heat change. So in his law, heat changes is also added to give a final product or to give a final output of a particular substance. So ang pinaka-focus po natin dito is the heat change and the thermochemical equations in calculating heats of reactions. So we have here the standard heat of formations of a compound is the change in enthalpy that accompanies the formation of 1 mole of the compound from its element, which with all substances in their standard states at 25 degrees Celsius. So in the standard heat of formation, each substance or each compound ay may tinatawag na standard heat formations na depende sa kanilang state, whether it's gas or solid. The change of heat formation of a free element in its standard state is 0. So nakikita natin din na change of enthalpy or heat change formation, standard heat formation. So we have this, the formula. Delta H, standard heat of formation, is equal to heat change, standard heat of formation of products, minus the reactants. Products minus reactants. That is the formula in getting the heat reaction, of a particular substance. So we have here the table that states about the standard enthalpies, the free energy of formation, and standard entropies at 298 Kelvin. In solving for the Hess's law, so kailangan natin gumamit ng ganitong table for us to mapadali ang paghahanap natin ng kanilang standard enthalpies, kasi each substances or compound is may equivalent na standard enthalpies, or shall we say the heat formation. So we have this formula. Calculate the enthalpy change in kilojoules for the following reaction. So we have this following shall we say thermochemical equation. Then use the enthalpy change for the combustion of the aluminum and iron. First is hahanapin natin yung kanilang heat of formations. Ito, then ito, then ito, then ito. Then ang lalabas for the aluminum is ang heat change niya is negative 1669.8 kilojoules. It is because it releases energy during the process, and this process is what we call the exothermic process. So for the iron naman, so we have this heat formation or the enthalpy change or heat change is negative 824.2 kilojoules, also negative, and matatawag natin siya na exothermic process. So next one. So dito sa solution, pinakita ko lang sa inyo na pinakita ko lang what is the solution for that. Ito siya. So, by just following this formula, the products minus the reactants, so 1,669.8 kilojoules minus 824.2 kilojoules, the answer is change in enthalpy is equal to negative 845 then kilojoules, or shall we say negative 845 kilojoules ang answer po sa combustion of aluminum and iron in terms to enthalpy changes. So next one, what is the standard heat of reaction for the decomposition of hydrogen peroxide? Same pa rin po ang gagawin natin. We just look for the heat formation of the following substances. Then kapag nakuha na natin siya, we can now apply the formula of the Hess's law na heat change is equal to the products minus the reactants. So ito po yung formula niya. Products minus reactants. So the hydrogen peroxide, the reaction, ito po ang kalalabasan niya. The products is negative 571.68 kilojoules minus negative 375.2 kilojoules, which is the reactants, and the answer for that is ito. Change in enthalpy is equal to, or heat change is equal to negative 196.48 times kilojoules, or 48 kilojoules. So that is the Hess's law. I hope that may napulot kayong lesson or aral sa discussion natin for today, which talks about thermochemistry. So that's all for today, and thank you for listening.